The idea of reducing commercial aircraft flight decks from 2 pilots to 1 has been discussed for decades. So, in this video, we take a look at why the United States has effectively ended the path towards single-pilot commercial flights, how the decision impacts Airbus's long-term plans, why European regulators reached the same conclusion, and what this means for the future of cockpit design. And be sure to check out Simpleflying's flight tracker. From live alerts and data on commercial, military and government flights, it goes way beyond your standard tracker. It was built specifically for avgeeks, free and live, right at your fingertips. The push toward reduced crew and single-pilot operations did not emerge as a radical redesign of commercial aviation, but as a cost and efficiency response to structural pressures facing airlines. Rising pilot demand, increasing training bottlenecks, and long-term labor shortages created incentives for manufacturers and operators to explore ways to reduce cockpit staffing without compromising safety. Within this context, the concept of extended minimum crew operations, or EMCO, gained traction as a transitional step, where one pilot would rest during cruise phases while automation and ground support systems maintained flight stability. More ambitious proposals followed. Single-pilot operations, or SIPO, in which one pilot would manage all phases of flight with varying degrees of automated or remote assistance, became the long-term theoretical endpoint of this design path. Airbus, alongside airline partners such as Cathay Pacific, explored these concepts through research programs that examined cockpit workload distribution, automation reliability, and human-machine interface design. However, even as technical studies advanced, the operational reality remained more complex. Safety analysis consistently highlighted the difficulty of replicating the redundancy of a 2-pilot cockpit. Aviation data from European authorities recorded hundreds of pilot incapacitation events between 2019 and 2024, underscoring that medical emergencies in the cockpit are not theoretical scenarios but recurring operational risks. In a dual-pilot system, such events are managed through immediate role substitution, workload redistribution, and coordinated decision-making. As a result, what began as an efficiency-driven concept increasingly became a regulatory debate centered on acceptable risk thresholds rather than technological feasibility alone. While manufacturers focused on improving automation reliability, pilot associations emphasized real-world scenarios where human redundancy proved decisive in preventing accidents. The turning point in the single-pilot debate came with a federal aviation law signed in February 2026 that removes ambiguity from cockpit crew requirements in the United States. Instead of leaving crew composition primarily to Federal Aviation Administration or FAA regulatory interpretation, the statute establishes a clear legal baseline that every commercial passenger flight must operate with a minimum of 2 qualified and fully rested pilots on the flight deck at all times. Under previous frameworks, concepts such as EMCO, where one pilot would rest during cruise while automation and monitoring systems assumed part of the workload, remained theoretically certifiable if safety cases could be demonstrated. The new legal language effectively removes that possibility in the US market by requiring continuous dual-pilot presence across all phases of flight, including cruise segments that were previously considered candidates for automation-supported reduction. Equally important is what the law blocks indirectly. SIPO, which represent the most advanced theoretical endpoint of cockpit automation research, are no longer a certifiable category for US commercial airlines under any foreseeable regulatory interpretation. Programs designed around reduced human workload in cruise phases, ground-based monitoring, and advanced flight envelope protection systems now lack a viable certification destination in the American market, regardless of technological maturity. Industry reactions to the legislation have largely focused on its scope rather than its intent. The decision also places the US in alignment with the most conservative interpretation of cockpit safety standards rather than a traditional one, signaling that future innovation will need to occur within a dual-crew framework rather than through its reduction. The legislative outcome in the United States did not occur in isolation. It reflects a broader regulatory convergence driven by safety assessments conducted over several years in both North America and Europe. At the core of the issue is the fundamental question of whether automation and remote assistance systems can reliably replicate the redundancy provided by a second human pilot in all operational scenarios, including rare but high-consequence events. European regulators had already moved toward a cautious position prior to the decision. In 2025, EASA concluded that current technology could not guarantee an equivalent level of safety to a two-pilot cockpit, and subsequently paused research into single-pilot operations. A key concern in these assessments has been the frequency and unpredictability of pilot incapacitation events. Data from European aviation safety monitoring recorded 287 such incidents between 2019 and 2024, averaging roughly one event every 6 to 7 days. While most incidents do not result in catastrophic outcomes under a two-pilot system, they highlight the operational reality that cockpit redundancy is not theoretical but regularly relied upon. Human factors analysis has reinforced these concerns. Aviation remains a domain where workload is uneven and situational awareness can shift rapidly, particularly during abnormal operations such as weather deviations, system failures, or air traffic conflicts. The presence of a second pilot provides not only redundancy in task execution, but also continuous cross-checking of decisions under stress. The most immediate impact of the February 2026 US law is not theoretical but programmatic, as it effectively removes regulatory viability from several high-profile industry initiatives that were built around reduced crew or single-pilot concepts. Among the most affected efforts is Airbus's work with Cathay Pacific under its Project Connect initiative. The program explored how advanced automation, ground support integration, and cockpit workload redistribution could enable extended minimum crew operations during cruise phases. With US law now mandating continuous dual-pilot presence, any certification pathway that depends on reduced in-flight staffing becomes incompatible with the largest commercial aviation market. Similarly, Lufthansa-linked trials examining cockpit workload reduction face a structural barrier. These studies were designed to evaluate how far automation and ground-based monitoring could safely extend pilot rest periods without compromising situational awareness or response time during abnormal operations. The US decision effectively removes the incentive for global standardization around such models, since aircraft certified or operated under reduced crew assumptions would still need to meet stricter dual crew requirements to access US routes. The European Across research project is also indirectly constrained. With the United States now codifying a strict two-pilot requirement, the likelihood of global alignment around single-pilot certification diminishes significantly, reducing the commercial rationale for continued investment in that direction. The trajectory of cockpit innovation is shifting away from crew reduction and toward workload optimization. Instead of designing systems to remove one pilot from the cockpit, manufacturers are increasingly focused on enhancing decision support, reducing fatigue, and improving coordination efficiency between pilots. This includes advances in predictive monitoring, automation-assisted checklist management, and improved human-machine interface design that supports shared situational awareness rather than replacing human redundancy. From an aircraft design perspective, this alignment reinforces the idea that future flight decks will evolve around collaboration between humans and automation rather than substitution. Even as artificial intelligence and autonomous systems become more capable, their role is increasingly defined as augmenting pilot performance rather than assuming control of critical flight phases independently. The most lasting effect of the 2026 US law is not simply the preservation of two pilot crews, but the creation of a structural ceiling on cockpit automation ambitions. By removing any certifiable pathway toward single-pilot operations, regulators have redirected innovation away from crew elimination and toward enhancing human performance within a fixed two-person framework. In practical terms, this means future breakthroughs in avionics and automation will be judged not by how many pilots they can replace, but by how effectively they can strengthen decision-making, coordination, and resilience inside an unchanged cockpit structure. What do you think? Should commercial aviation always require two pilots in the cockpit? Or do you believe technology will eventually become advanced enough to safely support single-pilot airline operations? Let us know by leaving a comment, and don't forget to subscribe for more aviation content. See you next time. In addition to our daily YouTube videos, Simple Flying publishes over 150 articles and a podcast every week. Visit simpleflying.com.